Welcome everyone. In today's video, we're going to talk about RAG or Retrieval Augmented Generation. This is one of the very fundamental concepts of using AI in general, but specifically in healthcare. Whether you are planning to develop an app or are just a user of the app or deploying one in your organization, this is something that you will need to understand. Don't worry if you're not technical. We will leave some of the technical deep dives for future videos. In today's video, we are only going to focus on some of the very basics. So let's start with something that hopefully all of you are very familiar with by now, and that is ChatGPT. Before ChatGPT became a thing, if you needed to search for some information, the way to find that was to basically go search. And search as we knew it was basically finding documents or articles that were relevant to the keywords that you were searching for. It was never really optimized for individualizing the responses to the questions that you were asking. And this is where LLMs like ChatGPT completely changed the game. They don't just search the information, they understand, or at least seem to understand, and then generate new text which is basically very tailored to your question. This leap from just being retrieving information to being able to retrieve and explain that information makes the ChatGPT and the other LLMs so transformative. But as powerful as they are, the LLMs suffer from a very big limitation, and that is that they cannot basically get you real-time data. They cannot connect to your data, your organization specific data, or they cannot find the latest information that you might want to connect with. And this is the problem that RAG is supposed to solve. So RAG stands for Retrieval Augmented Generation, and it is exactly what the name suggests. So it basically retrieves or searches the information based on your user query, and this search can be within your organization's data or a particular content that you have assigned it to. Then it augments the prompt that it gives to the LLM with that retrieved information, so that the generative text that comes back to you, the explanation that comes back to you, is a lot more context sensitive, and it is very individualized to your question. Let's jump into a demo to see an example of this, how it actually works in the real world. Okay, so I have basically ChatGPT open here, and I'm going to be following an example, a project that we have been working on internally here around continuous glucose monitoring. So I'll just ask it a very general question. When do you start a patient on CGM? I'm not even saying continuous glucose monitoring, and I'm just going to ask that question and see what it comes back with. And again, every time this will come on different answers, but you will notice in here is that it starts with the first thing saying is it can depend on individual clinical guidelines. And I have actually done this search multiple times, and you'll see every single time it has come up in some way to basically say that there should be some guidelines that you are following, but at the same time, here are some general guidelines that it provides. So let's try to do the same search, but see how this can change if we are using RAG. So I have an application that I have built. It's a very basic application that is just connecting to ChatGPT, but it is connecting it through an API, and I can actually go and change the model. So what I'm going to use is I'm going to use the GPT-4o, which is the same model that I'm using in here. So I'm basically going to just set it to ChatGPT-4o, and then I'm going to ask it the exact same question. But before I ask that question, what I have done is I have configured RAG, and we'll see how it works behind the scenes. But what it is basically doing is I'm giving it a set of these guidelines, right? So this is I've said is that, okay, these are the guidelines in my organizations for different treatment protocols. And in real world, these will obviously be full documents, but I've just written them for simplicity's sake as single lines that can help you understand the concept. and I'm going to go ahead and ask the same question. So when I ask that question in here, again, it is making the call to the same, backend of ChatGPT. But what you will see here is that it will say that it found something in the guidelines, and it says that start continuous glucose monitoring for patients with difficulty in achieving glycemic targets. If you look down in here, you'll see that there is actually a particular guideline that I had created. And again, it is not very specific, but this is kind of where we had trained the model to say that if you find a specific guideline, you basically follow it. And then it says that for additional context, CGM is often used for blah, 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 which is, again, there can be other text that kind of, came from the LLM. Now, if I go ahead and remove this and basically just say that that guideline is not available, and I ask the question again, let me just refresh it. So you will see that this time it will come back and say no specific protocol was found in the organization's guidelines. However, it continues to give you the default answer based on LLMs, how it is configured. And again, we will go back and look at in the backend how it is configured, but that gives you like an idea like how the LLM, or how basically we are bringing the power of the guidelines or the latest guidelines that is available and combining it with LLM. Now, just to clarify, I am not just sending this whole text to the LLM. I'm basically searching in this text and then specifics the specific guidelines. And again, we will see how that works in a minute in here too. Now, it's pretty clear that the results of the RAG heavily depend on how good the search or the original retrieval is. What you saw in the video there was not just search based on keywords. It's a special type of search called semantic search. And unlike traditional search that matches based on keywords, semantic search focuses on understanding the meaning or the intent of the question or the query and searches according to that. So how does that work? So let's break it down. So you take a list of documents, and using an algorithm, you convert these documents into a list of numbers that are known as vectors or embeddings. And these vectors represent the meaning of that document. And the way it is represented is like, you can think like a line pointing to a particular direction in a virtual universe. Now, when you ask a question or when you make a query, your query is also converted into a vector using the same algorithm. And then the similarity between your query and the documents is determined by the angle between the two virtual lines. It uses a mathematical concept called cosine similarity, which is like the angle between the cosine of the angle. If the angle is 0, the similarity is 1, which means that the document and the search term is exactly the same. If it is less than 0 or negative, that basically matches or tells you about how dissimilar they are. So again, let's just take a look at the demo to see an example of this, and hopefully that will become more clear. Okay, so for this part of the demo, I've actually just created some pages to help you understand the concepts and to keep things really simple. Instead of using full documents, I'll just use words or sentences. The concepts are still the same, but it just helps you to see, because then I can run it in memory and show you quick results. So what I have here is I have a form where there is a simple word, hyperglycemia. And if I just click this button, it will generate what we talked about, a vector. And again, these are a bunch of numbers that don't mean anything to you and me, but they mean a lot in the context of the algorithm that was used to generate them. This algorithm is again basically a model, an AI model. So in this case, I'm using a model for text embeddings that is provided by OpenAI. If I'm using a different model, then obviously these embeddings will be different, the numbers will be different, and they will have a different meaning in that particular model. Again, these really don't mean as a simple like word, but if I take it to the next step and I say, okay, I have two texts, the high blood sugar and hyperglycemia, and I want to compare these two texts. And what is happening in this case now is that it is creating those two vectors like the way I showed it there, and then using a mathematical formula, again the cosine similarity, it is giving me a number. And again, the number, the closer the number is to 1, that means the closer they are in their meanings. So if I basically just, copied this text from here to here and I just compare them, you'll see it becomes 1, which is again like the same word. So now you take this and you take it one step forward to say that, okay, how can I actually do some semantic search? And again, I'm using an example of simple titles in here or sentences, but this can apply to documents. So what I'm saying in here is, show me some articles on continuous glucose monitoring, and I've given it some titles. These are just random titles. These are not real articles or anything. And if I do the search, you will again see that it will go and find some articles to me and it will give me the confidence level for each of those articles. But it's not actually doing like a keyword search. It knows that these are related with diabetes and it finds the articles accordingly. And if I even type in here CGM and search for it, it is still able to find those articles and then come back to me with that results. Again, it is giving me a confidence level, so that can be used to determine. But the basic idea in here is that based on the list of articles that I gave it, it's able to find out which are more semantically close to that can be used for the result. And that's kind of what we were doing in the RAG here. When I basically asked it CGM, it did a semantic search. It found the articles that were closer to it, and it included those articles to the prompt that it sent to the LLM. So hopefully that gives you a good understanding of how RAG and semantic search work. This approach ensures that your app is grounded in reality, in your data, while still leveraging all the generative powers of LLM. But this can get better. As RAG, or traditional RAG as it is known, what we are saying in there is that you take the user query and you search it against the content that you have. What if you could actually take that query and give it to the LLM, where LLM using its knowledge can actually even generate the query better? This is what was actually happening in the demo that I showed you. So it's not just that the query is going past directly to the content, but it is actually being passed to the LLM, and the LLM decides what data does it need, and it can pull that data from those list of those guidelines. So let me now take you a little behind the scenes and show you exactly how the query was working. Okay, so we're going to take a peek at the code behind, and again, as I said before, we'll dive deeper into the code in future videos, but for today we'll just take a look at the prompt that is being sent to the ChatGPT, or the LLM in this case. And this is basically the prompt that we are sending it. So what I have here is, you are a knowledgeable medical assistant helping with treatment recommendation. You follow these steps. You search for the relevant guidelines. And the first thing there is, use the provided tool to search for exactly or closely related guidelines. This tool is what we have given it as RAG. So that is how it is configured in code, that these are the tools that is available to us. And the bot is smart enough to realize that which tool it needs to use. And then we give it additional guidelines. If no exact match is found in the first attempt, consider synonyms or other related terms, and then keep searching for other articles. And if you find the article, then basically give the response in one way. And if you don't find the article, then be clear and tell that no specific protocol was found in the guidelines. And if I go back to the demo, you can actually see that I have a log of everything that basically happened behind the scenes, and we can see how all this kind of worked out. So the first time I asked a question, the LLM searched for, I asked the question, when do you start a patient on CGM? But it actually did convert it to something different and said start continuous glucose monitoring. So you can see the LLM is using a different text, and it found a result which was a pretty, again, high similarity or confidence. And that's why this query just ended up here, and it gave me that answer right there. In the next time, it basically, when the question was asked, it found this but it actually found a different article because we had removed the original CGM article in there, and it analyzed this article and it realized that that is not relevant to it, and that's why it came back and it basically said that no specific guideline was found. Now, I have done this many times. Sometimes the LLM will actually do 2 or 3 searches. Sometimes it just stops with one. This is again more and more training of the bot, but the idea here is that it can actually go and search multiple times or figure out what are the best search terms are to make sure it finds the most relevant information. So hopefully that gives you a good overview of what RAG is and how you can leverage it in AI apps. We will be doing a lot of deep dives around RAG in general, but also how some of the other concepts of image analysis and around like how you can use AI in predictive DSI in our upcoming videos. If you have any feedback or any other comments, please contact us. We would love to collaborate with anyone that is building an app, or if you are an EHR that is working to integrate these apps in your system. Thanks again for watching, and till next time, cheers.